Now here is a sitter for you, a very easier one, a very repeated question. If 3 of the 6 vertices of a regular hexagon are chosen at random, then the probability that the triangle formed with these 3 chosen vertices is equilateral. So let us see the figure here first, what the question is all about. So this is the figure for you. There is a hexagon and we have to choose 3 vertex such that the triangle is equilateral. You can very easily see that this is a hexagon and we have chosen one equilateral triangle. There can be one more. If you join these 3 points, then there will be one more equilateral triangle which can be chosen on the vertices. So what is the required probability? The number of ways in which we can choose 3 vertex is 63 and there are only 2 equilateral triangles out of these. So the required probability is 2 by 6C3. So 6C3 is for us 6 into 5 into 4 upon 6. So the probability is definitely 1 by 10. So the correct option is the fourth one. Let us see the next problem. Here's the next question, which is related to the intersection of two circles. It says that if the angle of intersection at a point where the two circles with radii 5 and 12 centimeter intersect is 90 degree, then the length of their common chord is. So let us first see how the figure looks like. So here is the figure where the two circles are intersecting and it shows that this is a bigger circle whose radii is 12. So this is 12 for us and this is the smaller one whose radii is 5. So this is 5 and this is 12 and we have to find out the length of common chord. Now this angle is 90 degree. If I take this angle to be alpha, you can notice here that let us say this is point P where the circles are intersecting and this is the midpoint and I am marking it as M. Now you can notice here that the tan of alpha is equal to 5 by 12. So now if we are able to calculate the PM, then if we make it twice, then we will get the length of common chord. Now if tan alpha is 5 by 12, what is sin alpha? Sin alpha is 5 by 13. Now this sin alpha, that is 5 by 13, can also be written as PM upon 12. So here we are connecting the length PM. So from here you can see that the PM is actually equal to 60 upon 13 and the length is twice of PM. So this comes out to be 120 by 13. So this is the correct answer for us. So let us check where is this answer. It is option number 1. 120 by 13 is the length of common chord. Here's a straight question from the volume of parallelepiped formed by the vectors. These are the 3 vectors in terms of lambda and we have to find out the value of lambda when this volume is minimum. We know the scalar triple product will give you the volume of the parallelepiped. So the volume is actually equal to the scalar triple product of these 3 vectors which can be given in this determinant. So it is 1 lambda 1, again it is 0 1 lambda and a third is again lambda 0 1. If you straight away expand this, you will get a cubic relation in lambda, that is lambda cube minus lambda plus 1. Now we have to calculate when this volume is minimum. Now the concept of differentiation is definitely involved, but you know one thing, that the volume can be 0. If the scalar triple product is 0, then the volume is actually 0 as well. Now, if you closely look at the graph of this function, if I differentiate this function, let us see what we are going to have here. dv by d lambda is equal to 3 lambda square minus 1. If I equate this to 0, I will get two critical points, and the two critical points are 1 plus minus 1 upon root 3. These are the 2 points where you will get maxima and minima. If you check it out here, you will notice that if you double differentiate this, this is 6 lambda, and if you check at these 2 points, if you check at lambda equal to minus 1 by root 3, you will see this double derivative is negative. That means at this point you will get the maximum value, and again if you check at lambda equal to 1 upon root 3, this double derivative is positive. So, this is the point of minima actually. Now, there is a problem out here. Now, this is what we are going to see with the help of graph. So, here is the figure for us. You can notice the nature of the function. We have got 2 points. One is minus 1 by root 3. You can see up to minus 1 by root 3 the function is increasing, and at 1 by root 3 there is a minima, and this is what we have calculated. So, at 1 by root 3 we have minima, and at minus 1 by root 3 there is maxima. But again see here, just notice there is a point. There is a point where you are getting volume equal to 0. So, the volume can be equal to 0, and this is the conditions when the vectors are coplanar. Vectors are coplanar, and that is where you get the volume equal to 0, and this is the root of this cubic equation which we have differentiated, that is lambda cube minus lambda plus 1 is equal to 0. So, this is the particular point where the volume is becoming 0, and you can notice that this is lying somewhere between minus 2 and minus 1. So, the actual value has to be between minus 2 and minus 1, but since there is no option available here which is given in this problem, these are the options. So, we will be going for the most appropriate one where we have the local minima, and that option is 1 upon root 3. So, there is definitely an error in this problem, but we will be going for option number 1.